Another way of solving an LP problem where the number of variables are more than one and the graphical method cannot be applied. So we have to look at other ways of doing that, and we call that the simplest. Now the simplest has this. For this solving an LP problem using the simplest algorithm, we know that the standard problem is a maximization problem, right? So we solve a maximization problem and not a minimization problem. So the objective function should be a maximum. So if you are supposed to minimize, you have to negate your objective function so that it becomes maximized. And know that all the decision variables should be non-negative. And further, the constraints, right, the inequality should be a less or equal sign, where the C, the right hand side, should be positive. It shouldn't be non-negative. So if you want to solve an LP problem using the simplest algorithm, then these should be met, right? So if you want to use that method, you have to find a way of changing all the conditions to suit this problem. So there's just an example. This is how a standard maximization problem should be like. Maybe you want to maximize P equals to, this one you have three decision variables, X, Y, and Z, subject to these constraints, including an organic. Now you can see that the right hand sides are all positive, and the inequality signs are less or equal to, they are not greater, and we are maximizing. So with this, we can use the simplest method. And the simplest method is very simple. It's very simple. We just look at how to solve an LP problem using the simplest. But we'll begin with just a two problem. But these are the steps. That's some of the steps. The first step is that you convert the LP problem to a system of linear equations. Now, note that the problem given is an inequality, it's not an equation. So if you want to change it to an equation, we introduce some variables which we call slack variables. We introduce slack variables into the constraints, and the inequalities tend to equal signs. So an example with this, we know that all these are less or equal, change them to. So we'll be adding some values to this, like these three, which we call the slack variables, right? And they should be non-negative too. So the problem that we had, we can convert it to this. We have x plus y plus z. It was less or equal to 10, but we added a variable which is non-negative, right? Mm-hmm. And it tends to equal sign. The second constraint, we tend to equal by adding another variable, which is also a slack variable. And the last constraint, we tend to equal by adding another variable. Now, note this. I think that this one has shifted. When you are writing, it should not line up. It shouldn't line up. It should be something like diagonal from the left to the right. So, when you have plus x, then there should be a shift in that problem. Later, you understand why that is so. And we also include the objective function. We include the objective function. And mind you, the objective function, we rewrite everything. We put everything on one side and equate to 0. Right? That means initially we have no solution. Right? We have no optimal value and all this. So we're looking at that. Then the next step, after getting this, we write, if you've done solving systems of linear equations using matrices, we convert this to matrix form and we solve. Okay? Which we call the tableau. So we present the system of equations in a form of what is known as an augmented matrix. Let me just show you. If you have systems of equations, let's assume that we have x plus y plus z equals to 5, negative 3x minus 5y plus z equals to 3. Then let's say you have x minus 5z equals to negative 2, right? We'll turn this to matrix, and this is what we do. We first write out the coefficients. So we can call the matrix A. We just write the coefficient of the matrix. So this one, the coefficient of x is 1. For the first one, the coefficient of y is 1. The coefficient of z is 1. Then for the second equation, the coefficient of x is negative 3. The coefficient of y is negative 5. The coefficient of z is 1. The last equation, the coefficient of x is 1. Coefficient of y is 0. Because we don't have any y component. Then the coefficient of z is negative 5. So this is a matrix. Then right hand side, we call it just a matrix C. Right? For the first equation is 5. The second equation is 3. And the third equation is negative 2. Now, we transform this, in matrix form. If we've done matrices, matrix multiplication before, then this will be 1, 1, 1, negative 3, negative 5, 1, 1, 0, negative 5 times x, y, z is equal to the right hand side 5, 3, and 2. Okay. So that means we've written systems of equations in a matrix form. So when you multiply matrix multiplication, the first row to the first column, you have x plus y plus z, and that's what we have. It's equal to 5. Then the next row, you have negative 3x
negative
plus
5
plus negative 5y plus z, right? Is equal to 3, and that's what we have. Okay. So in solving, if we, let's say we are solving these systems of equations, matrix approach. When we say an augmented matrix, that means we combine these two matrices, right? This matrix A with C. So we have 1, 1, 1, negative 3, negative 5, 1, 1, 0, negative 5, and mostly we have a line here, right? It can be dashed. Then you have 5, 3, and 2. So whenever you see this, at times they are dashed. It means that the matrix is augmented, right? And it can tell you that, okay, this is a system of equations. So that's what we mean by writing it in augmented form. So let's see how to write this on augmented form. This is just to show you what an augmented matrix is. So you convert to an augmented matrix, and that's what we call a tableau. And that will be your first tableau, right, in the table form. So you convert this to that, and it becomes this, right? But this one is 3 variables. We start with just a simple problem with 2 variables. Then we look at how to solve. Then after that, we select what is known as a pivot column. A pivot column. Now, let's look at the table. We see the last row is the objective function. Okay, the last row actually is the objective function. So you look at the most non-negative indicator. Okay, yes, from the objective, the most non-negative indicator. In this case, is negative 2. Okay, so when you take all the negative value, when you take the magnitude, this one is the most negative. Okay, so this column, the x column that you see here, is known as your pivot column. It's known as a pivot column. Now, you divide your right hand side. Oh, everything has shifted, but these are the right hand side. That's the answer, right? You divide the right hand side by the x values, excluding the last one. So maybe 10 divided by 1, 3 divided by 4, 10 divided by 2. Then we look at the one that is least, right? And that row 2 becomes your pivot row. So the element there that intersects both the pivot column and the pivot row becomes your pivot value or your pivot element. Then we use that. I think I'll quickly look at an example. We'll quickly look at an example to explain the remaining procedure, because the thing has shifted to very difficult. So let's quickly look at this two variable. We want to maximize p is equal to 5x plus 4y subject to the following constraint: 3x plus 5y less or equal to 78, 4x plus y less or equal to 36. Then the non-negative constraints where x and y are more equal to 0. So we want to solve this problem. We want to maximize it. We want to use the LP. And the first step we looked at is to rewrite the problem in a standard form by introducing what is known as slack variables. So let's look at objective function together with the constraint. So the first constraint, we have 3x plus 5y. Then we add, I think we have only two variables, so we can add the next one straightforward. We add a slack variable, let's say u. Then it tends to equal sign. So let me bring the equal sign somewhere here. It tends to equal sign. We have 78. Then the next one, we have 4x plus y. Now, we'll not line up with this. You come this way, and let's call that slack variable w, and this should be equal to 36. Then with the objective function, what do we do is we push everything to one side and equate to 0. Right? Push everything to one side and equate to 0. So we can have negative 5x minus 4y then plus p, right, equal to 0. And it can be seen here. So we have p minus 5x minus 4y equals to 0. So that's the same thing. Negative 5x minus 4y plus p equals to 0. Right? So that's the same thing. So we've changed this problem into standard form like this. Then the next step is to create a tableau or the augmented matrix. So we have the x, the y, the variables u, w, and p. U, w, and p. So we augment. We'll have the right hand side. So let's write the matrix. This will be 3, 1. Sorry, 3, 5, right?
Yes.
The coefficient of y 5. Coefficient of u is 1. No w, no p, right? And the right hand side is what? 78. The next one, 4, 1. No u. W is 1.
No p.
The
36.
right hand side is 36. So this is the constraint. Then the objective function, we have negative 5.
Negative 4.
Negative 4.
0.
0.
0. 1.
The right hand side is
0.
Now, so the last row is the objective function. Now you look at the variables u, w, and p. The columns, as we see them, they are what is known as unit columns. Right, unit columns. And the variables x and y, the columns are not unit columns. So in simple algorithm, all that we want to do is we want to see if we can convert these columns to unit columns. If we are going to do that, then whatever value we have here, now we don't have any solution. Whatever value we have here will be the solution, right? And the variables, the values that we see here will be the
Answers.
The variables that we are looking at. So first, we look at from the last row, we look at the most negative value from the last row. And the most negative value is -5, right? So this column, a blue marker, so this column becomes the pivot column. This column becomes the pivot column. So then from the pivot column, we look at the values and we divide by the right hand side. Right? So we can have 78 divided by 3. 78 divided by 3, and that will give us 26, right? And 36 divided by 4 will give us 9. Okay.
Yes,
Now, this gives us the minimum positive value. We look at the positive, right? On the right hand side, the column, we look at the least positive value. While on the last row, we look at the most negative value. Okay, so in magnitude terms, we are just looking at the value, the positive values after dividing by the pivot column, value from the pivot column. Which one is smaller? Right, so the one smaller, and in this case, you can see that it's 9, so it's this row. So this row becomes what is known as the pivot row. Pivot row. Then in that case, the value 4 becomes the pivot element. Pivot element. So when you get the pivot element, what you want to do, I think you have not done Gaussian elimination. What we want to do is I want to make sure that this is 1. Right? The pivot element is 1, and all other values in the column are 0. Are you okay? And the column is 0. So let's first, how do you make this 1? I think we divide by 4.
Yes.
Are you okay? So replace this row 2. So replace row 2 by 1/4 row 2. Are you okay?
Yes,
so
sir.
We have another tableau. That's why I started. So we have to write out another tableau. UWP. We draw it so. So we have 3,
5, 1,
1,
0, 0,
0, 0,
7, 8.
7, 8. 8. Then 1/4 of this will give us 1, right?
1, yes.
Then times 1/4. This will be 0.
0.
This will be
1/4.
1/4.
0.
0. So this on 4 is 9.
Yes.
Then for the last row we have -5, -4,
0,
0,
0, 1,
1,
0.
0. Let's continue here. So the next thing is we want to make sure that this column is a unit column. That means all values apart from the pivot row should be zeros. So what we do to make sure that the first one is, so we can multiply the second row by 3, subtract from this to replace row 1. So we can say that we can let row 1 be replaced by row 1 minus 3, row 2. Then the last row, the third row, what do? We can multiply row 2 by 5, right, and add to
And add to row 3.
So we can say that row 3 should be replaced by row 3 plus 5 row 2.
So wouldn't it be row? The second wouldn't it be row 2 plus 5?
Which one?
Oh, okay. I
We
understand.
multiply this by 5.
Yes.
We have to
Yes.
go to 0.
Yes.
So at the next tableau we have x, y, u, w,
UP.
So let's see. Row 1. So 3 times this, so this will give us 0.
Yes.
Right. Then
That will be 3 over 4
3 over 4.
times 5.
No. 5 minus 3 over 4.
4.
5 minus 3 over 4. What do you be? That's what would be 5 minus
3 over 4.
3 over 4. This is what? 9. 4 times 4, that's 20. 20
Yes.
minus 7. 20 minus 3, 17.
Yes.
17 over 4.
4.
Right. So this will be 17 over 4. Then what about this one? This is 0. So still, now will it be 1?
That will be 3 times 0.
This will still be 1.
Yes.
1 minus that. Then this one, that is 3 over 4. So 0 minus 3 over 4, that is negative 3 over 4.
Yes.
Then this one will be 0. Then what about this one? 3 times 9. 3 times 9 is 36, right?
Yes, 36.
So 78 minus 36 to 52. Will it be 52?
I'm coming.
52, right?
78 minus
Minus 36.
36. 42.
What do? We multiply this by 3. 9 times 3 is what? 27.
9 by 3. So it's not 36.
9 by
Yes, 27.
27. So
Yes.
it will be 78 minus 27.
78
51, right?
minus 27. Yes, 51.
51. And this one is 1 over 4. 0. 1 over 4.
0.
0 and 9.
Yes.
Then the last row, row 3, is row 3 plus 5, row 2. So this will give us 0. So 5 times this.
So that will be 5 over 4.
So 5 over 4. So row 3 actually is negative 4
Yes.
plus 5 over 4.
Yes, sir.
So what do we have? Negative 16. 5 minus 16. Negative
11.
9. What is that?
5 minus 16.
Negative 11.
Yes.
Negative 11. So this one is negative 11 over 4.
Then we'll go to 0. So it will be 5 times. So that is 0.
This one is 0.
Yes.
And this one, I think you get 5 over 4.
Yes.
1. Then the right hand side will be 45. That's when you continue with the
Oh, so
calculation. So you see now.
so meaning that all the rest should be 0.
No.
Only the
No.
first one.
So the first one,
Oh, okay.
we are done. So now this column is a unit column. Now we look at, after that, we look at the last row again. That is the objective function row. Are there any negatives? Are you okay?
Yes.
So there's still another negative, and this is the only negative. So obviously, this becomes our pivot column. Okay, so if this is a pivot column, what will be the pivot row? That's what you have to look at. Right? And how do we determine the pivot row? We divide the right hand side by these two. Are you okay? So 51 divided by 17 over 4 is like 51 times 4 over 17. So that will give us what? 51 times 4 over 17. I think the answer is 12 or so. And this one too. 4 times 9 will give you 36, right?
Yes.
So when you look at the two, which one is least? The 12.
12.
Are you okay?
Yes.
So this row becomes our pivot row. Okay.
Yes.
So if it's a pivot row, then definitely this is the pivot element. Pivot element, it should tend to 1. So how do you make sure that it's 1? So row 1. We multiply by 4 over 17.
Yes.
So 4 over 17. So let's look at this. I think I can clean this one. I bought this one, that's why I have to clean this. So we'll be creating tableaus. So if the variables are many, but the clue is, if there are no negatives, right? Even if after writing, converting the objective function into, how do you call it? The tableau, and there are no negatives at the last row, you are done. That is the solution. Never write that. So it can be that just after one iteration, because just after one iteration, the row will have no negatives, then you are done. So far as there are negatives, you continue. If there are none, then you are done. So row 1, so you have X, Y, U, W, and P.
Recorded.
So let's look at this. So row 1 is 4 on 7 row. So 0, this will be 1, right?
Yes.
So 4 over 7, row 1. So this is 4 over 17. So what will be this? Negative 3. No. You have 4 over 17 times
Negative 3 over 4.
That's negative 3 over 17. This one is 0. Then what about this one? This is 12, right? Okay. With 12. Then you have 1 over 4, 0, 1 over 4, 0, and 9. Then the last row, 0, negative 11 over 4.
Then 0, 5 over 4, 1, 45.
So what do we know is that these two should go to 0. Are you okay? So why can we make this 0? So row 2 should be replaced by R1 minus 1 over 4
R2.
Hey. No.
So you are making
R2, it should be R2 minus 1 over 4 R1.
So you say you are making 1 over 4 0. But 1 over 4 0 is on R2.
It's on R2.
Yes.
So when you have R2, now 1 over 4 R1.
So that means you are.
And so you multiply this by 1 over 4. 1. Okay, if you multiply this by 1 over 4, then whatever we have here minus
R2.
Will replace R2.
Oh, okay.
Then R3 will be replaced by R3 plus 11 over 4 R1. So that one to be multiplied R1 by 11 over 4.
Then you add it to negative, yes.
And we add to row 3.
Row 3.
So the next tableau will be, let me just the line is not part.
Okay.
This is not part of the table. Let me just. The next tab we have X, Y, U, W, and P. Then the right hand side is there. So we have 0, 1. Oh, sorry, let's R1. Are you placing R1? No.
No, sir.
0, 1, 4 over 17, negative 3 over 17.
Then 0,
0 and
12.
Then R2, 1 over 4 R1. So 1 over 4 times this is 0. This one, so this will be 1. And this will go to 0, right?
Yes.
So 1 over 4 times R1. So 1 over 4
times 4 over 17.
4 over 17. That is 1 over 17. Then R2 minus that. So this is R2.
So it will be 1 over 17.
To be negative, right?
Yes.
Negative 1 over 17. Then the next one, R1. So negative 3 over 17 times 1 over 4. Then this minus that. And when you calculate, you get 20 over 51. This will give you 0. Then this one, we multiply 1 over 4 by 9. Okay? And that will give you 9 over 4. Minus. No. By R1, sorry.
Yes,
1
sir.
over 4
By 12.
by 12. That gives us 3. Okay?
Yes.
Then 9 minus 3 will give us what?
6.
Then the last row, R3 is replaced by R3 plus 11 over 4 R1. So let's say 11 over 4. That should be 0.
Times 0, yes.
Plus
0.
that should be 0. And this will also be 0, right?
Yes.
Then when we come here, 11 over 4 times
4 over 17.
4 over 17. That is 11 over 17.
Yes.
Okay.
Because it will cancel out.
No. Is it not negative 1?
No, sir, it says R1. So 4 over 17.
Which 4 over 17?
So the R1, where your hand is. You see, say 11 over 4 times R1. So we are on U.
11 over 4
times this.
times this.
Yes.
And so you have 11 over 17.
Yes.
11 over 17. Then R3, which is 5 over 4. So you have 5 over 4 minus 11 over 17. And when you simplify, you get 52 over 51. Have I left? Sorry. It will be 11 over 17. Here. We are here.
Yes.
Right. So that will be 11 over 17. Because when we add to whatever we have, because we got 11 over 17, when we add to 0,
it will give you the same
It
answer.
is this one. This
So,
one will give us 52 over 51. And then when we go on, we try.
Okay.
Then this will give us 1. It still be 1. Alright. Because let's see. 11 over 4 times R1. That's
0.
Then plus
1.
and this one, the right hand side, we turn to 70. 78. And then we can try this. R1 12. So 11 over. Let's try the last one. 11 over 4 times R1, which is 12. Then R3 value is 45.
Yes.
So 45 plus this.
3.
This will give us 3.
33.
So 45 plus 33.
Will give you 78.
70.
Yes.
Now, so
Exactly.
after this, we check the last row again. Are there any negatives?
No.
No, there are no negatives. So that means we are done with the alteration. Now, when we finish, we look at pivot columns. Okay, we look at pivot columns. So when you look at this, now how do you? That's a pivot column. We look at unit columns.
Okay.
Okay, every column. We look at this. So when you look at a unit column, so this one for x. Okay. So
Yes.
that means our x is equal to 12. This one is for y. Are you okay? Sorry, that means our x is equal to 6. Okay. Now this one is for y. And
It's
y
equal
is
to 12.
Then the solution is that. So you can look at u. U is not a unit column. So that
W2 is not a unit column.
So
But
after that, all variables that doesn't have unit columns are 0. Right? All of them will be 0. So that is how we do the simplest. So with this, we have arrived at the solution. So the U and W's are termed non-basic solutions. The x and y's are the basic solutions. So this one, x will be equal to 6 because the x column, the unit value corresponds to this. So it means x is 6.
Yes.
And the y one corresponds to this. Y is 12.
It's 12.
Y is equal to 12. And what we have here is the optimal solution. So our optimal solution, our P is equal to 78. Because when you look at it, you can see that, right? This column is also a unit column. So our P is 70. So that is it. And U is 0. W is also 0. So that's it. And you were told to maximize this. P equals to 5x plus 4y. So even if when you substitute x equals to 5, sorry, x equals to 6 and y equals to 12, the answer will be 78. That is it. Okay.
Okay, sir.